Hi, in this video, I'll be showing you how to calculate the force of friction between an object and a surface using my measurement device that I've created. So, first you'll need a test surface. I'm using paper for this video. I'm just going to tape it down to the platform here. Once you've done that, you can take your object and place it on the platform. So if it's sliding, that means that you've already reached theta critical and you have to probably take that angle down. So right now, if I leave it resting, it's not sliding. So we have to increase the angle. And if it slides while you're increasing it, you can't necessarily account that as a measurement because there is some oscillation when you're turning it. So I don't suggest using that as a measurement. First you have to turn it, stop turning it and reset it, and then test it. Now it fell that time, so that means that we've reached theta critical, but we might be over it, so we have to go down a little bit and test it again. So it's still not reached it yet. You gotta go down just a bit more. Now it's not moving, so we have to go up. Okay, it's moving now, and it's consistently moving at S. So we can consider that this is theta critical for a protractor on a piece of paper. And we can measure that in two ways, either using the built-in protractor, which reads about 22 or 23. So I'm going to write that down, 22, 3. And we can also calculate it, though, more precisely with a ruler and a formula I've created. So the measurement between the end of protractor and I'm talking about this protractor that's in the device, not the one we're actually measuring. The end of the protractor and the end of the rail, which is a distance of 141 millimeters. So I'll mark that down, 141. And then we can plug that into the formula. And this measurement allows us to figure out the angle using the cosine, because here we've created a right angle triangle. So this is vertical, and it creates a right angle with the horizontal base. So we have a right angle here, and then the platform length is the hypotenuse. So using the cosine of this length divided by the horizontal length, we can figure out the angle. And in my formula, you have to add a certain value which compensates for the length of the protractor and a bit of the length at the end here to get a correct reading. But anyway, the formula shows that for 141 millimeters of x, the angle is 24.5 degrees. So 24.5. So it's pretty close to the protractor reading, just about 1.5 off. So it's pretty good, but not perfect for the protractor. This is more accurate. So I'll use this value when I'm calculating the force of friction. And next, once you have theta critical, you can put this device aside, and now you just need a scale. So using the scale, I'll measure the mass of the protractor, which is 6 grams. And we have to convert that 6 grams to kilos because kilos is the SI base unit for mass. So 6 divided by 1,000 will be 0.06. 0.006. So 6 divided by 1,000 will be 0.006 kilograms. that will be one of the measurements we need to plug into our formula. So first we need to find the normal force, and I'll come back and explain what that is. So the normal force is the y dimension of the force of gravity. So the force of gravity goes straight down like this. But if we're looking at a platform, we can split it into two dimensions. So the y going perpendicular to the platform and x going with the platform. So the normal force is the y dimension of gravity, which is equal, and that's not just the y dimension of gravity, but y dimension of the weight, so mass times gravity, which is equal to mass times gravity times the cosine of theta. So with that, we can figure out the value of the normal force. It will be 0.006 times 9.81, the constant of gravity, times on Earth, times the cosine of 24.5. And this should give us the normal force in newtons exerted on that protractor that's being tested here. So that will be 0.053 and more newtons. With that, we have part of the constant of friction, or the force of friction. Now we have to calculate the constant of friction. So that was the normal force, which is part of the force of friction. The force of friction is equal to the normal force times the constant of friction, mu. So now we have to calculate mu. Mu is equal to the tangent of theta critical, which is tangent of 24.5. So that would be 0.455 for mu. So now that we know the normal force and mu, we can figure out the force of friction that is in between the piece of paper and the protractor. So that will be 0.455 mu times the normal force, which is 0.0535. And on my calculator, I'll do it a little bit more precisely without rounding. So that gives us a total force of friction of 0.0244 newtons. So there you have it. You can calculate the force of friction between two objects. And this can be incredibly useful for calculating the efficiency of cars, for example, because friction is a force that moves against, or it doesn't move, but it goes against the direction of motion of an object, so it will take away from the propulsion of that car. And friction is different from the force of drag. The force of drag is a solid moving through a fluid. So, for example, my hand moving through the air experiences drag, not friction. But if two solids are together, my hand on this table, that's friction. So we have just measured the friction of an object. For measuring the force that goes against a car, you'd have to measure drag and friction because there's tires on the ground and the body of the car is in the air. But for this experiment, for example, a protractor doesn't really have much drag because it's so thin. So that's how you calculate the force of drag, and thank you for watching the video.